Hello, everyone. How are you guys doing today? So, I think we'll be able to finish section 1.4 today. If we finish section 1.4 today, that means we have Thursday. Oh, so today is Thursday. Oh man, I thought today is Tuesday for some reason. Wow. Okay, so.
Will we have our first unit test next week, Tuesday or next week?
Thursday. Okay. Exactly 1 week from today. So yeah, we'll be able to finish 1.4 today. So tomorrow we are going to start 1.5, but it will not be in the exam. And on next week, Tuesday, if you have any questions, then I'm going to do a review. If you don't have any questions, I'll continue 1.5. And also, I'm going to tell you tomorrow. Tomorrow, no, I didn't make the exam yet. On Tuesday, I'm going to tell you what will be in the exam from the review sheet. Okay, so I'm planning to make the exam over the weekend. So I have an idea what to tell you.
Do we need the TI?
I'll take a look at the review sheet. I forgot what I have in the review sheet. Most likely you don't need it because we didn't do anything that requires calculator besides regression. But for regression, I said I'm going to give you easy one, but you have to memorize the formula for A and B. Yeah, so most likely for this exam, you don't need calculator. Any other question? I don't know why. I feel like yesterday was Monday and today is Tuesday. That's why when they have their club hours, I was like, today's Tuesday. Why do they have their club hours today? Tomorrow you have a quiz. And the quiz will be based on domain, I think. We are doing the domain today, yeah. The quiz will be on domain. 1.4. Domain question. We started domain in our last class. Do you remember? Depending on 5 types of, actually not 5, 4 types of function, we find the domain differently. So we didn't finish our section or the topic yet. Today we're going to finish it. And tomorrow you're going to have a quiz. Okay? Tomorrow there will be quiz on domain. I'll give you one of these 4 types of functions, and then you're going to find the domain in interval notation. So let me refresh your memory with the 4 types. For polynomial and odd root, there is no problem. So domain is everything. For even root function, we cannot have anything negative inside the square root or 4th root or 6th root. So to solve this problem, we take the function inside the radical, set it bigger than or equal 0, solve for x. Then we have rational. For rational, our problem is the denominator. Guys, class started. For rational, we have denominator problem. So for denominator, we don't want the denominator to be 0, not x to be 0, denominator to be 0. Denominator cannot be 0. So we take the function from the denominator, set it not equals to 0, solve for x. So from the number line, we take the entire number line from negative to positive infinity. We just omit those numbers, but we cannot have the denominator. Then we have third type, rational function with even root of the denominator. If we have the same even root, but not on the numerator, the denominator, then this time that denominator cannot be 0 and also cannot be negative. So the only thing this denominator can be is positive. So we take the function inside the radical on the denominator and make it strictly bigger than 0. Solve for x. And then the last time, we have even root on the top and a polynomial on the bottom. So there are 2 problems. The top is telling us we cannot have negative inside the radical, and the bottom is telling us that we cannot have 0 on the denominator. So we find each denominator, each domain separately, and we see where do they intersect. That's our final domain. Okay. Any question, comment, concern, complaint? So we did a few examples in our last class. We saw one denominator that gave us two numbers that we cannot plug in for x. So we break our interval into 3 pieces. Then we saw two denominators. So we have to find the domain separately for each, put them together on the number line and see where we get at the end. Then we have double denominators. For double denominators, you have to consider each denominator separately and see where do they intersect. And then we started even root, and we know even root, the inside function cannot be negative. It can be 0, it can be positive, it cannot be negative. So we said it's bigger than or equals to 0, solve for x. So it's one-sided since we have only x inside the radical. And now we are going to do similar case, but this time we don't have only x inside the radical, we have x squared inside the radical. So, how do we start? So we know whatever we have inside that function, x squared minus 16 can be 0 or it can be positive. Right? Whatever we have inside, that result can be 0 or can be positive. Now, when we get 0 for this scenario, we can solve for x manually. We add 16 to both sides. We get x squared is 16. So basically it's asking what number when you square becomes 16? Definitely 4. But is 4 the only number when you square you get 16? Negative 4 also. So you cannot forget about your negative number. When you take the square root, so basically you have to take the square root of both sides. And anytime you take the square root of a variable, you have two choices, either positive or negative. So that thing becomes 0 when we have x equals 4 or x equals negative 4. So in the number line, we have negative 4 and we have positive 4. And our y is 0 here, right? You can, but people forget about the negative sign. So that's why I ask you, what number when you square you get 16? So y is 0 here, y is 0 here, right? When x is negative 4 and x is positive 4, our y is 0. It's true, right? When x is 4, we have 4 square minus 16, 0 for y. When x is negative 4, we have negative 4 square minus 16 is also 0. So when x is negative 4 or positive 4, our y is 0, strictly 0. But now we want to know when we have positive y. Do we have positive y in this interval? Do we have positive y in this interval? Or do we have positive y in this interval? We have to figure out when we have positive y. We know definitely y is 0, when x is negative and positive 4. We know that for sure because we solved it. But in between where we have positive y, we cannot know it, so we have to solve it. Let's pick any number for x smaller than negative 4. Pick any number that is smaller than negative 4. Negative 5. When x is negative 5, What do you get for y? Negative 5 square minus 16. What is negative 5 square? 25. 25 minus 16, is it positive or negative? Positive. So definitely in this interval, our y is positive. So this will be inside our domain. We can pick any number from negative infinity to negative 4 and replace our x with in this interval, in this function. Now let's see in the next interval, what do you get? Any number between negative 4 to positive 4. 0. So when you replace, we get 0 square minus 16. So 0 minus 16, and what do we have? Negative. So y is negative here. So can you take any now? Can you replace with any number from negative 4 to positive 4? We cannot, because then we have a negative inside the radical. We cannot have negative inside the radical. Well, if it makes your life easier, let's do this. So you can see why do we care. Because this is our y. Do you have a problem? Negative inside the radical. So we cannot take anything from negative 4 to positive 4. Negative 4. Positive 4. And then we have our last interval. Any number more than 4. Pick any number more than 4. 5. So when x is 5, we get square root of 5 square minus 16. And you already did that in the first part. It's 25 minus 16, which is square root of positive. It's valid, right? Square root of positive number is valid. So this is positive y. So we are going to take this interval in the domain. That means you can replace x with any number from negative infinity to negative 4. And we can replace x with any number from 4 to positive infinity. This is infinity symbol. Oops. So there are only one set of numbers that you cannot replace our x with in the middle. So we write our domain in interval notation. What is the first interval? The first shaded part. Negative infinity to negative 4. And can you use x with negative 4? When x is negative 4, what's the y? 0. And square root of 0, is it a real number or not real? Real. So yes, we can substitute x with negative 4. It's a real number. If you can substitute, it's bracket. If you cannot substitute, then it's parentheses. So here we can. We get square root of 0, which is 0. And now we cannot take anything from the middle, but we can take everything from the third interval. So how do we write the third interval? Infinity parenthesis. So basically, you can pick any x value from this interval, replace here, you get a valid y. Take any x value from here, replace here, you get valid y value. The only thing you cannot replace your x with is all the numbers from negative 4 to positive 4. For example, you may think, no, I want to substitute x with negative 3. Well, no problem. Negative 3 square. What is negative 3 square? 9. What is 9 minus 16? Negative 1. So square for negative numbers. Is it real? No. You can try substituting, but that's not going to work. So this is our domain. Means what number you allowed to substitute your x with. To the left one, we didn't have to do all this because we had only one x value to work with at the end. When we solve for x, we have only one x. X is less than or equal to -1. But now we have two values for x. Since we have two values for x, so we end up getting three intervals. So we have to check each interval individually to see which one gives us valid results. Any question? And guess what? Department loves this kind of question. So there's a high possibility of seeing this in the final exam. Try the next one by yourself. But first you have to identify what type of equation, what type of function you have. And it's a rational plus something else. So it's a rational with even root on the denominator. So there are two problems. Denominator cannot be 0 and even root cannot be negative. So what can it be? It cannot be 0 and also it cannot be negative. So what can it be? Strictly greater than 0. It has to be positive. So that's how you start. And now find out what are the x values you're allowed to substitute. So this is rational with even root on the denominator. Rational Oh, let me check that. Today is 9/11. Dominica, Salahuddin, Arslan, Maxine, Zoe, Claire, Jolene, Prince, Hayden, Ellen, Asir, Kylie, Alice, no phone, Jasmina, Alexandra, Jennifer, Jessie, Johnny, Afiz, Karin, Pedro, Erika, Jawad, Ruby, Saum, Dimitri, Siki, Amir, William. Ready, guys? Erika, right? How to do this, Erika? X square minus 16 greater than 0. You cannot do that. You cannot take the square root until your X square term is alone. So you can add 16, get this, and then you can take the square root. Okay? The radical doesn't work individually. The radical works as a whole power. You can try taking the square root, but then you get into trouble because that symbol, it's neither flip, neither stay. It's neither flip nor stay. When you take the square root, the inequality get flunky, like it doesn't work anymore. So you shouldn't take the square root here. You can do x squared equals 4, take the square root, so you get x equals 16, and then you get x equals plus minus 4. This is true. When x squared is 16, it means we have x either 4 or positive 4. Positive 4 or negative 4. But you cannot say x is bigger than positive and negative 4. It doesn't make sense. True. So you saw it. Okay, Erika, then what did you do? Number line. So this is our number line, negative infinity, positive infinity, negative 4, positive 4. Positive 4 and negative 4 will make the y 0. Right? When x is 4, we have 4 squared 16, 16 minus 16 is 0 on the denominator. And you have negative 4 squared 16, 16 minus 16 is 0 on the denominator. So you cannot substitute 4 and negative 4 because they will make the denominator 0. So you can say x is negative 5 here, x is positive 5 here. And you also have to pick something from the between negative and positive 4. Here, x equals, what did you say? 3? Sure. And then you have to check each one of them. Which one makes the radical positive? Because this is what you're looking for. Strictly positive. So we have negative 5 squared minus 16, which is 25 minus 16. 25 minus 16, positive. So this will be inside the domain. How about the middle? We had 3 squared minus 16, which is 9 minus 16. What is 9 minus 16? Negative. So can you have the middle interval in a domain? Now the last one. We have 5 squared minus 16. That gives us 25 minus 16. Do you get positive or negative? Positive. So we can use this interval because that gives us positive. So this is actually same as this one, but not exactly same. So domain is negative infinity to negative 4 union 4 to infinity. Now this time, can you replace x with negative 4 on the denominator? Can you replace x with positive 4 on the denominator? So if you cannot replace x with a number, what do you put for that boundary? Bracket or parenthesis? If you cannot replace the number, parenthesis. So the only difference between the left and the right page is in the left page, when x is negative 4, we have no problem because we have square root of 0, which is a real number. But when you replace here, we have square root of 0 on the denominator, but denominator cannot be 0. So you cannot replace 4 or negative 4 in this equation because that makes the denominator 0, makes everything invalid. Okay? Any question? Is there anybody who is lost about all this process? Johnny, tell me, where did you get lost? Which part? No, numerator is a polynomial, we don't care. When x is negative 4, replace here. Negative 4 square, what is negative 4 square? And you have 16 minus 16, what do you have? So you have 0 on the denominator. Is this real or invalid? So can you replace x with negative 4? If you cannot replace, that is parenthesis. It says go up to negative 4, but cannot use negative 4. Same thing here. You can start from negative 4, but cannot use negative 4. Any other question? And now we have the last type. Even root on top means on the numerator. And we have polynomial on the denominator. So you have two problems because we have two types of function together. How do you solve even root problem? Greater than 0. Can it be 0? Why not? If you have 0 on the numerator, what is square root of 0? Square root of 0 on the numerator is possible. If you have 0 over a number, it's real. But if you have a number over a 0, it's undefined. It doesn't exist. So you can have 0 on the top, but you cannot have 0 on the bottom. So numerator top can be bigger than or equal 0. What's wrong with the rational? What's wrong with the denominator? Cannot be 0. So denominator cannot be 0. So you have two functions, so two requirements. Solve each one and then see why do they meet. Jolene. 4 to infinity. And you cannot have anything smaller than 4. Okay. Let's say x is 2. When x is 2, we have y equals 2 minus 1 and then 2 minus 4. What is square root of 2 minus 1? Square root of 1, right? Over negative 2. What is square root of 1? Is this real or unreal? It's real. So see, it can't have more smaller than 4. The final domain has to be a combination of numerator and denominator. So yeah, for denominator, you did half. So you have two problems, solve them and see where do they meet. For which number, what problem is solved? Is it for entire number line, or is it for only a few numbers, or is it for at least half of the interval? And then I have one more question, so let me put it here. 3x minus x squared. Y equals, I'm coming, y equals 3x minus x squared. Yeah, and then do I have more? Oh man, one more. Square minus 6x. Y equals x squared minus 6x plus 8. And then see, do I have more? Come on, how many more I have? Okay, one more, 49 minus x squared. Y equals square root of 49 minus x squared. Yeah. Try all these four. So whatever function is given inside the stuff. And I will give you and then the combination. What point is it? G and A problem. You can do it all your no, but that's a common.
Yeah. This is the.
Where you go through the school,
Either.
even roots, so it means these are square roots. And these are four roots. These are six roots. So I internet even roots. What's color? You can have them color. Or you can have like square roots. This is square roots. This is four roots. So what's wrong with even roots?
Is it good? Like,
So even roots. What is what? So you get 0. Not for everything. You just take a problem, not number. Okay. You problem is you cannot have unity. So I don't problem unity.
So how do you
The no negative is what? And 0 or positive.
how do you solve?
So whenever you get inside your radical, not only x, but you can even inside the radical, you take it and instead it equals 0, or it can be positive.
Also, so example, so this is x minus 6. So that's the minus 6. So how do you write the how do you write the this is
And then
that one.
so you have 2 x, and
This
you
one.
cannot choose the number less.
Yeah.
Or the radical. Or it
So you said 0, so how do you write it? Says
you send you get it.
Oh, no, I said the second.
oh
Yeah.
also oh
So when x is big, 0, and when is positive, or this.
it's okay.
The right is only. Good. You
I
didn't get no one?
you don't huh? You don't I'm bad at patient. Bad. I am bad.
What are you thinking?
I was just talking about
Can you always?
your favorite friend. Sorry. I show.
What is the right name? Yes, we did not get it. That's it.
Yo, when you start having
Not like that. Or this
no,
two. This two, they have only square roots.
so that really,
Yeah,
oh, wait,
4 questions.
wait, I need how much? Probably around 2.
So you got only 1. Now try this, the top
So you said it's
one.
wait, you said it's
This is 0, equals 0.
oh, very,
You only 1 number, right?
oh, yeah.
That's why it will, it's 0. But when you get 2x value, you choose the number like to check.
Oh,
3x minus x squared. Why you cannot? Why one is 26? Check. When x is 1, we is got a 0. Is got a 0, you run 0. So we can use it.
Okay.
But there are 2 numbers, right? So what is the other number? Anytime it's square, it's not to check. So what time is it? So you have 2 numbers.
If it's 1 x value, greater than
Check
0.
which
If
interval.
it's 2, no, nah, I said, See you.
Oh, yes, 3. So y is 3. That's not what I do. 3 times 3 is 9. Equivalent is 3.
I know.
And you don't get chain 4 for the first one, you get chain 4 for the second one. Okay, then it is 3. So y is 3.
Yo, I didn't see.
Here, 3 minus 1. 3 minus 2 maybe 2.
Yeah,
3 minus 1 is 3, but 3 minus 6 adds 2.
he got on the easy class. Oh, from Monday to Wednesday, he had less classes than me. And I got Monday class. And today, he only has 1 class, and it's 1.
You have
I don't get it.
2,
So,
you have 4,
Because
right?
like I have way more.
You have to check this is a what you said.
Yeah, that's what I'm saying.
You check this.
That's just his media is looking at us.
Can you say things that are true in this?
So,
You
yeah,
find
okay.
something. You can.
It's like, it's like,
But in general, once you have 2 vectors,
you know,
it actually goes
like when you make flyers.
1 by 1. So this is a this is a T of the
Yeah, I think it's that.
have 2.
I don't remember. He told me that. Weeks. But I think
Here's the quiz in there. Show me every difference.
yeah.
And expect me to know in green.
He told me that last week.
You
So I told him to lie. That's what
I'm not gonna. You should probably listen.
Listen. He's worse than me.
Ask.
Yo, I helped him. No. Yes, I helped him. Tell you.
Wow.
Wow. Wow.
I thought I should have helped.
Yo.
You should teach us something.
Yeah, like I even had to show you.
For specific for, especially for the important ones. We're not sure if the.
Yo, she's talking.
X is 3, X is
Bro, I'm so stuck on the first call.
when you see generating number, we have let's see, okay, makes sense. Out together with 3. So what's the domain here?
So she told me, yes, you go to the. Wait, right? This, we need a.
So you're saying you can take negative results.
Just
If you think anything on the left side, no, what I mean is this. This is a fast interval, right?
You get it?
But what result you get from fast interval? Can you have a negative result in and how can you put this in the domain? Basic. Domain is what number it can substitute.
Like, something to say.
So for us,
Why?
you get to that meaning to the solution. Next factor.
Oh, factor.
You must factor it. One second.
So how funny factor? Actually goes great.
But you know that, you just check.
But how like
Results, it did. No.
you said I can do that. Yeah, you can. You said I can.
Okay, what is this?
That's fine. Yeah, X2 minus 3. I can go here. Okay, no, it's great.
Right, so. but they have one number of that, you know. So this is bigger than equal 0. So this should be bigger than 1. When you do the square root, then you can make it. But here you have the square, you want a single x. The single x is known. You can add 1 to both sides, so you get x is bigger than or equal to 1. So starting from 1, everything bigger than 1 is allowed here. And when you come to denominator, the only thing you cannot grab the denominator is 4. So denominator is telling you that you can use intent on the line, but you cannot use 4. Right? So this is the denominator. The result from the denominator. But the result from the numerator. So when you look at both of them together, what is the smallest number you can plug in for your function? Can you plug in 2? Not 2, 0. Can you plug in 0 in the function? When you use this.
Yeah.
So looking at 2, you're looking at
I think
so you have 2 numbers together. Why did we intersect? Why did we intersect? What is the smallest number you have in both intersections? What is the smallest number you have that have both solutions? Which number has both solutions? Starting from which number? That's it. We have to start your domain from 1. And you're allowed to use 1, so you're going to have bracket here.
so 2A.
So from 1 until point up to 4. That means you cannot have 4, so you have to break down. But you cannot do this. You cannot pick 0. 0 makes the numerator noise. You see, you're saying that you can take anything from here. Can you? So what is the smallest number you have to start with? 1. The first number should be 1. Good. Until which number? 4. Okay. Here, correct,
Yeah.
but here, something like we need to factor. We need a square.
Oh yeah.
Anything is square and an x, the goal should be factoring, so we can do this.
Also, you say the narrow back.
We cannot reverse. Reverse is
Maybe like so.
right, so you have to factor out x.
We have.
Question.
Oh wait. Oh shit. Okay, yeah.
Background knowledge.
Oh here.
Exactly. But this is the other way around. Once you get some. Oh yeah.
No, because I
You cannot use that.
no. But this is negative.
This is 3x minus x plus 2x, 3x minus x. That actually means things. We study the problem. That's nothing.
So why-
That is correct.
She said small social. It's only a handful around whatever is square these.
We can have 0 for this one.
Well, do you have to figure X or X?
No.
Yeah.
Let's think what we can have inside minus 1. what you can have. Inside this ratio, you can have 0, and you can have positive numbers. No negative. So that's where you start. It can be 0, or it can be positive. So it can be 0, it's fine. You can find a 0. Today it was 0.
Wait, 0.
Or what? Divided square roots, right? And square root of the numerator or the denominator? So it is on the numerator or is it the denominator? In the function. For the numerator, yes, it's function. The denominator, it cannot sit down. So here is the numerator, it's that from there. We take the function, now, so for that route, we now you have to set that so for x.
So 3 minus x.
And then x equals 0. X equals 0, so minus x equals 0.
Yeah. But my time is like 5.
For example, here,
Okay.
expenditure here,
Apple is better.
so again, for this scenario,
Got Kool-Aid. Watermelon, please. Okay. Are you banana?
I choose on the two sides, that is on the middle.
Cheating with it.
It depends. Check. Possibly check the number line. The number line, which one is true? The middle column here or the end column? When you're looking for. Yeah, but that's for the x negative x squared is 162. From 45, 49 minus 49 minus 64 negative. Number one. If you get the number line and it's a huge interval, which interval makes the outcome positive?
What? Oh, so I don't want to.
Yes, when you check the number line.
Wait,
Oh,
we
so
have.
you must check. Otherwise, positive and one is positive. So in the number line, we have negative, infinity, and positive. Somewhere you have 0 and somewhere you have 3. You know when it's 0 and y is 0 and when it's 3 and y is 0. So these two definitely you know, they make the y 0. But how about these intervals? Which of these make your y 2 times 3? You're looking for positive.
Yeah.
Let's pick a number from each interval and see which number makes this or that.
So you say, well, you can't use 0.
You cannot use 0 because 0 is the wrong number.
Oh, okay, so let's say it's negative 1. So yeah.
So, probably, yeah,
And check if it's positive.
if it's positive, that means it's allowed. It's negative, it's not.
Also, like for this, 4. I have to plug in. How about the 1?
You should.
Just be 1.
You should plug in everything. Actually, you can plug in 1 and then the other one out the next.
Don't you get like decimal food?
Correct. For example, if you have 2 integers, the next you get decimal digit.
Because I figured like you make 1 together. The square root.
But here, problem is fine. You have to pick decimal point, you have 2 integers. For example, 3 and 4, they are next to one another. Is the integer between them. We have to put a decimal.
Yo, what's your name?
You can solve for x. Solve for x.
I think it's fine.
Let's do them together.
Yeah,
No,
so
please.
anything clear? Anything clear? Anything present? That's it.
So for the last problem, we have two functions together. Each function have their individual problem. The problem for the first one is the function inside can be bigger than 0 or equals to 0, but cannot be negative. So we take x plus 1, and it said either it's equal 0 or it can be bigger than 0. And since it's only x, so we have no problem. So enough plus minus. So we can simply solve for x here because there's only one x. We don't have any two x's. There's only one x here. So x is bigger than or equal 1. So if you want to put it on the number line, no, let me put it a little bit down. This is the number line. Come on. Let me do it here. Let me save it. I have to close it. Close. I'm going to refresh. Mine too. It's hurting so badly. Yeah. So we have negative infinity, positive infinity, and we have 1 here. The numerator says start from 1, and you can have anything bigger than 1. This is the domain for top. Now let's look at the domain for the denominator. Denominator has its own problem. It cannot be 0. So we have x minus 4. This cannot be 0. So x cannot be what number? 4. You are adding 4 to both sides. So x cannot be 4. X equals 4 is here. So our second denominator says, hey, don't take 4. Don't take it. But you can take anything after 4. Or you can take anything before 4. That's the denominator. Now my question is, where do you see both domain intersect? From which number both domain starts? From which number you see both of the?
1.
Good, 1. See at 1, both domain has the, at 1 you have both of the domain. That means you have to start from 1. So at 1, you can take for the top, and also you can take for the denominator. So while x is 1, the whole thing is real. So you can use 1, so it's bracket. And then from 1 until where you have both of the domain together. 4. So you go to 4. But can you use 4 in your function? No, because that makes the denominator invalid. Numerator is valid, but denominator is invalid. So you cannot take it. And then again, it starts from 4. Oops. It starts from 4. And then why is its ending? Infinity. So you know, it starts from 4, but you cannot take it. You go up to infinity. So that's the domain for this function. Two functions together, find individual domain, and then see their intersection. The next one is very similar. We start with the problem. Function inside the radical can be 0 or it can be positive. It can be 0 or positive. Now this time we have x squared inside. When you have x squared inside, you don't have to use inequality sign because we want to see the positive. Or if you can use inequality, but that will make things harder. So you start with the function 3x minus x squared can be 0 or it can be positive. And now you cannot divide it by x because if you divide by variable anytime, you're going to lose a solution. So the only thing you can do is factoring out. You can factor out x, you get 3 minus x equals 0. You solve each one of them separately. 3 minus x 0, so x is 3. So you have x equals 0, x equals 3. So this is for 0 part. You know definitely your y is 0 when x is 0 or x is 3. But you also have to find out positive when you have positive y. That's why you need the number line. Because seeing 0 is easy, but seeing positive is not easy. Now if you observe this, both factor has 1 power, right? They both have 1 power, invisible 1 power. So when you have odd powers, there is actually a good thing about odd powers of the factor. For the number line, you don't have to find each interval. You can find one interval and the other interval will alternate. So for example, we have 0 and we have 3. Negative infinity is here, positive infinity here. So before I showed by choosing a x value from each interval, substitute and figuring out the number. That's the normal method. But let's say you didn't have time. You have only 1 minute where you have to figure out the solution. So in that case, you can find only one interval and the other interval will change the sign. For example, you can take a number from 0 to 3. What number you want to take from 0 to 3? 2. And then replace inside the radical or in the factor, it doesn't matter. You had 3 times 2, 6, minus 2 square 4. What is 6 minus 4? 2, which is positive. So if this is positive, automatically this will be negative and this will be negative because they alternate sign, and it alternate only for odd vectors. For even factors, it doesn't alternate. For odd factors, it does alternate. So you don't have to find all 3, find one of them, and then change the sign for the other intervals. That means the only numbers that you're allowed to use in this function is which interval? 0 to 3. So domain starts from 0 and 3. How about their ending, their boundary? Parentheses or bracket? Bracket, because we can use them. We can use x equals 0 and we can use x equals 3. We are allowed to do them. We are allowed to use them. So that's the domain for this question. The next one is the same story. We have only square root on the numerator. So same scenario happen. Since we have a square, anytime you have a square, try not to use the inequality. Write this way. X squared minus 6x plus 8 can be 0 or positive. It can be 0 or it can be positive. And again, we have to factor 0 or positive. What two numbers multiply to 8 combine to -6? -4, -2. So you solve for x. X minus 4 equals 0, x minus 2 equals 0. So x equals 4 and x equals 2. And if you observe these factors, each factor has which power, what degree? 1 here and 1 here. So they have odd degree. That means we don't have to find individual interval. You can find one interval and alternate the sign. So in the number line, we have -infinity to +infinity, somewhere 2 and somewhere 4. Now this time, let me pick something from here. X equals 0. When x is 0, we get square root of, we can use this function, 0 minus 4 and 0 minus 2. What is 0 minus 4? -4. And what is 0 minus 2? And if you multiply to negative, you get positive. So this is positive. That means what's the next interval? Negative. And if this interval is negative, what's the next interval? Positive. For odd power factors, the sign alternates. So you find one of them and the other one alternates. If you have plus, that means this is minus. If this is minus, that means it has to be plus. If this is minus, then it has to be plus, and then this has to be minus. So you alternate sign. Since we are looking for only positive things, so this domain will have the two ending, the first and the last interval. So what is our domain? Where do we start our domain? Or to infinity. So the first interval here is this one. The third interval here is this one. You take both intervals, and that's the domain. Basically, you're saying from these, you can pick any x value and substitute. But don't pick anything between 2 and 4. You'll get something invalid. Any question? So the other two questions follows the same rule. Find the number line. Now the last thing I want to show you is composite functions. Domain of the composite function. If they do not give you the composite function itself, that means first you have to find the composite function and then find the domain. And you're going to do same thing. You're going to check where this composite function makes sense. So let me see one of them. For example, here, I have only two questions. Let's try the first one. It says find f of g. F of g of x. So you're putting the g function inside your f function, right? F of g means put g inside f. So you get 1 over square root of your g function, 2x minus 3. So first find the composite function and then find the domain. So now what type of function we end up getting here? Which type is this? From the four types I gave you. Which type is it? It's rational and even root on the denominator. So we have even root on the denominator problem. So can the denominator be 0? No. Can the even root be negative? No. So you cannot have any negative, you cannot have any 0. That means the only thing you can have is bigger than 0. So you take this 2x minus 3 and set it bigger than 0. And this time you have only 1x, so you don't have to use the number line. I mean, you don't have to test the number line. We can simply solve here. You add 3 to both sides. You get 2x is bigger than 3. Divide by 2. You get x is bigger than 3/2. Means start from 3/2. Take everything bigger than that. But can it use 3/2 for x? No, because that makes the denominator 0. So what's the boundary for 3/2? Parenthesis. So find the composite function and find the domain based on the 4 types I showed you before. So tomorrow we are going to do, and with this we are done with 1.4. So next week, Tuesday, you have homework 1.4. And also tomorrow you have a quiz on domain. I'll give you one of these types, one of these 4 types. One of these 4 problem. One of these 4 types of problem. I'll give you one of these 4 scenarios, and then you're going to find the domain. Don't be late tomorrow. Have a good day today. See you again tomorrow. Asir, right?
Is this on?
Huh?
The thing was crazy. This one is more complicated.
But we already did that, right? It's an even root on the denominator. So as long as you know these 4 types, we did that. Come on, here. See the second problem, even root on the denominator. So you already know that.
So confused.
You need to go to the